Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Sofiya binti Muhammad ZAKIAMANI, student ID 2021449902. And today, our group, which is group 3 from RS1202A, will be presenting about the topic thermal physics. So, let's get on to it. So, what is thermal physics? Thermal physics is the integrated study of thermodynamics, statistical mechanics, and gas kinetic theory. Generally speaking, thermal physics studies about the statistical nature of physical system from an energetic perspective. In a simple way, thermal physics is a study about heat and temperature. Thermal physics deals with the internal energy of objects as a result of the mobility of the atoms and molecules that make up those objects, as well as the movement of this energy or heat between objects. Now, we will continue on the topic specific heat and specific heat capacity.
Hi, Assalamualaikum. My name is NATASHA AMIERA binti SHAUDI, and I will present about specific heat and specific heat capacity. First, I will talk about the definition of heat capacity, which is C. Heat capacity is total heat is required increasing the temperature of an object to 1 degree Celsius, and the SI unit is Joule kg, the power of -1, or Joule degree Celsius, the power of -1. Then I will talk more about the heat capacity, which is C. Heat capacity is have greater amount of heat are needed to raise the temperature of solid or liquid to higher values. The amount of heat, which is Q, is directly proportional to the change in temperature. And there is the formula for heat capacity, which is C equal to Q per delta T, which is C is heat capacity, Q is heat, and T is the temperature. I will talk about specific heat capacity, which is Q. Greater amount of heat required to raise the temperature of greater mass material. The heat capacity of the system is proportional to the mass of the system. Q positive if heat flows into the system, and Q negative if heat flows out the system. So the formula for specific heat capacity is Q equal to mc delta T, which is Q is the energy transfer, M is mass, C is the specific heat capacity, and delta T is the temperature. And the last one is application in daily life. When you heat up a pot of water on the stove, the pot heat up faster. Although you are putting the same amount of heat on both substances, the pot responds quicker than the water because the water has a high heat capacity. I think that is all from this topic. And now we will be looking at latent heat and change of phase. Thank you.
Hi, Assalamualaikum. My name is MIRA ARDILA binti JOHARI. I am from RS1202A. My student ID is 2021A4174. I am going to present about latent heat and change of phase. There are two types of latent heat. The first one is latent heat of fusion, and the second one is latent heat of vaporization. In fusion process, heat required to convert 1 kg of solid material to liquid, while in vaporization process, heat required to convert 1 kg of liquid material to vapor. The equation of latent heat is Q equal to mL, where Q is the change of the heat, and M is the mass of the substance, and L is the specific latent heat. The next one is change of phase, or also known as phase transition. It occurs whenever the physical characteristic of the substance change from one form to another. Only the system internal energy change during a phase transition. The temperature of the substance remains constant. The amount of substance involved determines how much energy is exchanged during a phase change. Examples of change of phase. The first one, solid to liquid, which also known as melting. And the second one is liquid to gas, or we call as boiling. Next one is application of latent heat in daily life. The example is boiling water on a stove. It occurs when thermal energy from the heating element is transferred to the pot and in turn to the water. When enough energy is supplied, liquid water expands to form water vapor and the water boils. That's all from me. Now let's continue with heat transfer mechanism.
Assalamualaikum. My name is IMANINA Sofiya binti BAZLI. I will be talking about heat transfer mechanism. As you can see in this slide, there are three types of heat transfer mechanism, which is conduction, convection, and radiation. I will be explaining them one by one. So, what is conduction? Conduction is the most common form of heat transfer and occur via physical contact. Conduction occurs when the atom or molecule in the hotter part of the material vibrate or move with a greater energy than those in a cooler part. The rate of heat flow through a substance is proportional to the difference in temperature between its ends. So now look at this example. When a person touches a hot object with their hand, thermal energy is transferred from the object to their hand through conduction. Next, the heat from a hot cup of tea makes the cup itself hot. Third, ironing of clothes where the heat is conducted from the iron to the clothes. Lastly, the example of an experiment of heat being transferred by conduction is that if a metal spoon is heated at one end, its temperature rises at other hand. So, we need to know about the conduction formula. The first one is heat flow over a time interval, which is given by this equation. And then heat flux in the rate of heat transfer per unit area, given by this equation. So we can arrange this equation to get the formula of thermal conductivity. Next, convection. Convection is the process of heat transfer by the movement of molecules that occur within fluids such as gases and liquid. There is two convection, which is natural convection and forced convection. Natural convection occur due to beyond force, as there is a difference in density caused by the difference in temperature. For example, oceanic winds and the cycling movement of boiling water in a pot. Lastly, forced convection occur when a mechanical tool is used to move a fluid in order to heat, cool, or dry an object. For the example is blowers, fans, and pumps. That's all from me. After this, Sofiya will be present about radiation.
Hi, Assalamualaikum. My name is AINA Sofiya binti DOLAMIDIN, and we will continue with radiation. What is radiation? Radiation is the process in which energy is transferred by means of electromagnetic waves. In the topic radiation, we will be looking at the Stephen Boltzmann law. This law stated that the rate of an object radiates energy is proportional to the force power of its absolute temperature. This is the Stephen Boltzmann law formula. Even P is equals to A times sigma times T the power of 4, or P equals to A times E times sigma times T the power of 4, where P is equals to energy over time equals to power, A equals to area, T is equals to temperature in Kelvin, sigma is equals to the Stephen Boltzmann constant, and E is the emissivity for the object, and the emissivity for air is 1. That's all from me. Thank you.
Here are the references that we use for our presentation. That's all from our group. Thank you for your attention.